Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi bin Muhammad Isa from Group 14. First of all, I want to present about what is a nuclear reaction. Nuclear reaction is the process through which the structure of nuclei is altered as a result of energetic particle bombardment. During a nuclear reaction, energy is absorbed or released. The total atomic number and total mass number must always be equal or balanced on both sides of the equation in nuclear reactions. There are several types of observations were made on nuclear reactions. First, Ernest Rutherford. Rutherford was the first to make observations of nuclear reactions by performing collisions between alpha particles and nitrogen atoms. Second, Chadwick. Chadwick discovered the neutron by bombarding an alpha particle with a beryllium atom. Third, J.D. Cockcroft and E.T.S. Walton. Cockcroft and Walton explains producing a nuclear reactions where lithium was attacked with accelerated protons, resulting in the production of two helium nuclei or alpha particles.
What is nuclear fusion and nuclear fission? Nuclear fission. Nuclear fission is a reaction when a heavy core divides into two lighter nuclei which are close to the mass of neutron and energy emission. Nuclear fission also can emit more energy than the energy released through chemical reactions. The nuclear fusion also can be divided into two types, which is spontaneous fission and induced fission. So now, nuclear fusion. Nuclear fusion is a type reaction that fuses two light nuclei into a heavier nucleus when huge quantity of energy are released. The energy released in this reaction is called thermonuclear energy. The thermonuclear energy is an energy that obtained after nuclear fusion or nuclear fission of atomic nuclei at a very high temperature. The nuclear fusion reaction also can occur in fusion bomb and in the core of a star. Nuclear fusion in the Sun. The main nuclear reaction taking place in the core of the Sun. To begin, 4 protons from the hydrogen nuclei combine in a pair to produce 2 deuterium nuclei, each of which contain a red proton and blue neutron. Each nucleus emits an electron and a yellow flash of energy when it is created. Then an additional proton is added to each of 2 nuclei, resulting in 2 helium-3 nuclei with 2 protons and 1 neutron each. During this phase, a yellow flash signifies energy emission 1 mole. Finally, the 2 helium-3 nuclei combine to form a single helium-4 nucleus, consisting of 2 protons and 2 neutrons. 2 protons and a yellow flash of energy are emitted as this final nucleus is formed. The overall result of this reaction is conversion of 4 hydrogen nuclei into 1 helium nucleus. The yellow flash indicate the energy being released at each stage.
Which nuclear reaction is stronger, fusion or fission? The answer is fusion reaction. This is because fusion reaction yields more energy than the nuclear fission reaction. Fission reaction will only produce more energy when it splits larger nuclei, while fusion reaction combines small nuclei to form a larger nucleus. Fusion reaction is a spontaneous reaction, while fission reaction can be controlled. The condition that need to fusion reaction occurs is it need a really hot temperature and high pressure.
Okay, in this slide I want to tell about differences between nuclear fission and nuclear fission. Before this slide, my friend Hadi and Dan already talked about nuclear reaction, nuclear fission, and nuclear fission. Okay, for the nuclear fission, only an atom split into the light nucleus to do the nuclear reaction. But for the nuclear fusion, which 2 or more light nuclei collide with each other. That means 2 or more nuclei involved. And then the second differences is each atom split a tremendous amount of energy is released. But the nuclear fusion, the energy released during the nuclear fusion is several times greater than the energy released during nuclear fusion. Okay. The third difference is fission reaction do not occur in naturally, but the fusion occur in the star and the sun. And the fourth difference, the little energy is needed to split an atom in fusion reaction, but the nuclear fission, high energy is needed to bring fuse two or more atoms together in fission reaction. And the example for the nuclear fission is atomic bomb. And the example for the nuclear fusion is the hydrogen bomb. Yes.